this afternoon. Thank you all for taking time this afternoon to join us. We are here for our October edition of the Canon Health Sciences, or KHS Webinar Series. And this month, we have the pleasure to be joined by Sandra Stevens, Dr. Sandra Stevens from Belmont University in Tennessee. And this session, I think, is quite special because our second-year doctoral student, June, actually recommended, it'd be wonderful if we could bring Dr. Stevens in. So thank you for that recommendation, June, and I'm so glad she was able to join us here today. For our panel, anyone in the webinar is more than welcome to ask questions. You can do so through the chat. Dr. Stevens is willing and able to ask questions as they arise. So we'll keep an eye on the chat for you all. And then our panelists, I just wanted to highlight, we have several students that have a lot of interest in aquatic research, and they're in different stages of their career. So I'm really glad that they're able to join us here today as well. So first we have Christopher Long. He is a second-year master's student. He has his official thesis proposal later today. So really excited for his upcoming aquatic research. And we have Dr. Mike V. And I apologize, I say Dr. V because Mike, I apologize, can you properly pronounce your last name?
It's Vakula.
Thank you, and I'm so sorry. I'm just going to default to Dr. V, my apologies. Mike is quite accomplished. He's a recent graduate from our PhD program and has extensive experience in aquatic research. So thank you for joining us today. And fresh with jet lag, we also have Dr. Young Kim joining us. So thank you. I'm glad you're able to join us today. I know the time change has been challenging. He as well has done some extensive aquatic research and has a registered report published and ready to get going here with a new study. And last but not least, our recommender for today's session, we have Johnson Park. He's a second-year doctoral student working with Dr. Talon Lauder, and has a lot of interest in aquatic research. So I'm really glad that you're all able to join today. Without further ado, our speaker today, we have Dr. Sandra Stevens. So again, really excited for this recommendation. And Dr. Stevens, your work is really, truly outstanding. I think we're really going to learn and enjoy today's session, talking about a little bit of an emphasis maybe on aquatic research, but really you've done so much with special populations, working with individuals with gait impairment, and also a lot of work with promotion of physical activity and use with physical disabilities. So just really commend you with your work and appreciate you to take the opportunity to join us here today.
Oh, thank you. It's exciting to be here.
And I'd say what we'll do here is to transition. The panelists, we are going to actually close out our videos and really pass the virtual baton here to Dr. Stevens. And I will mute my mic, but I'll keep a close eye on the chat for the audience today. So without further ado, Dr. Stevens.
Oh, thank you. Well, I'm going to try to share my screen here so we can get started. Let's go. Started at the end, so let's go back to the beginning. Maybe be a good place to start. Okay. Well, I just want to say how excited I am to be here. That I've been involved with, the underwater treadmill research for, over a decade, and it's, one of my favorite things to talk about. So I'm very excited to have the opportunity to share that with you. I'm currently at Belmont University, and that's a recent transition, but the lab where all of our work has been done is in the Aquatic Research Center at Middle Tennessee State University. So I, like I said, take this opportunity to tell you a little bit about what we're doing in our lab. Let's see if I can get this to. So one of the things that we kind of started looking at is that just the kind of components of walking, and the idea that walking is really essential to being able to fully participate in activities of daily living and just participation in the community in general. So in our laboratory, we've analyzed a lot of ambulatory movement in a variety of ways, and we've looked at how much energy is consumed during various locomotor activities, and then tried to quantify the gait patterns and force levels that children use and adults as they walk or run. And as our understanding of human locomotion has increased, we've sought to extend our findings to persons with neuromuscular disabilities, metabolic disorders, and explore some interventions that might improve mobility in people who have these physical challenges. So our initial studies in this area featured children with cerebral palsy, or what I'll refer to as CP. And what we know about this population is that children with CP tend to develop compensatory strategies to enable them to walk. And these can lead to excessive forces and high levels of fatigue and overuse. And over time, this increase in physical stress can lead to difficulty in maintaining the energy needed to sustain ambulation, which in turn can reduce participation in home, school, and community-based activities. So in designing an intervention that might be useful in helping children with cerebral palsy to walk with greater ease, we began thinking about the use of underwater treadmills as a possible therapeutic option. And this water-based gait intervention has been used in, let's see if I in veterinary clinics, and it's helped restore gait in greyhounds and racehorses and assisting in their return to the track, and by some sports medicine specialists to try to speed up the recovery of injured athletes. But from a therapeutic standpoint, the potential benefits of exercising in an underwater treadmill, especially if you have neuromuscular disease, include increases in strength from overcoming the water resistance and turbulence, and enhanced heart function and venous return from exercising in a semi-weightless environment, and just the greater body weight support that it provides. So in our first study, we documented the impact of underwater treadmill walking on the walking performance of children and adolescents with spastic cerebral palsy. These participants varied greatly in their locomotion ability. Participants in this study completed 3 training sessions per week for 10 weeks, and each session featured 3 built-in walks and then some rest periods in between. In order to increase their total exercise volume, changes in water, height, walking speed, and duration were staggered, and every 2 weeks, so that, like I said, those variables changed. And you can kind of see from the picture that the equipment that we used was a HydroTrack, which we were just discussing with Sarah. It now has been purchased by HydroWorks, and so there's a little bit of a monopoly on the equipment right now. Now, results from our cerebral palsy study indicated that participants in the experimental group demonstrated an average increase of 17% in preferred walking speed, while members of the control group, who carried on with their normal living activities but did not participate in the training program, displayed no significant change. So you can see here was our control group, and then here's the experimental group. In a similar fashion, the maximal walking speed increased by an average of 20% among the participants in the experimental group. And lastly, the amount of distance covered while walking for 5 minutes, which reflects aerobic endurance, rose by 16% in the experimental group, but remained stable among the members of the control group. So overall, our findings revealed substantial and meaningful improvements in various measures of walking performance in youth with cerebral palsy following a structured program of underwater treadmill training. In addition, positive gains in leg strength were observed in our participants. And based on the success of this initial project, I started wondering if underwater treadmill training might produce positive changes in mobility for other physically challenged individuals. And I considered implementing this type of training for persons with spinal cord injuries. And I selected that population to start with because they tend to be young, healthy individuals, and figured if we were going to start in this neurologically challenged populations, it would be good to start with a group who might demonstrate responses if they were present. Prior to beginning that, though, I really wanted to understand just the relationship between physical activity and quality of life in adults with spinal cord injury, because if there wasn't any relationship, it didn't seem feasible to try to do something that would increase physical activity if it didn't have an impact on quality of life. So findings from that initial exploratory study revealed a strong positive association between physical activity level and quality of life in people with incomplete spinal cord injuries. Like I said, as the eventual goal of many people with spinal cord injury is to eventually stand or walk, I became interested then in quantifying the relationships among preferred walking speed, leg strength, and daily step activity in this population of adults. So I determined that physical activity did have an impact, and then trying to look a little closer at what limits ambulation in this population, and tried to explore the relationship between leg strength, freely chosen walking speed, and daily step activity. So this was kind of the study that explored those variables. So you can see in this figure that there's a very straight linear relationship between leg strength and daily step activity. So that basically just means that the higher levels of leg strength were tied very directly to improvements in daily step activity. The stronger your legs were, the more steps you took per day. However, looking at this figure, what we realized is once the participants hit about 1 mile an hour, the increases in daily step activity were much more rapid. So you could increase speed up to a point with no significant change, that even if you were able to walk a little bit faster, you still were not taking very many steps per day. But once you hit this kind of critical point, then the increase was exponential. So from a therapeutic perspective, this study provided support for the importance of leg strength and freely chosen walking speed as two important potential determinants of community-based walking activity in individuals with cerebral palsy. And that really kind of supported the idea that maybe working with this group in the underwater treadmill would be beneficial. So after completing those two preliminary studies and realizing the importance that leg strength and walking speed play in increasing daily step activity, we began exploring the idea of employing the underwater treadmill training in adults with incomplete spinal cord injury. And thinking about that, we first reviewed the use of land-based therapies to improve gait in that population. And there are quite a variety of gait interventions which are currently used to promote the recovery of walking in people with spinal cord injury. And they include treadmill-based training using, in this case, manual assistance, robotic assistance, and then electrical stimulation. And while all of those methods have been shown to enhance walking ability, there are some drawbacks that have been associated with each form of that. And one of the problems is that you need, for providing this type of training, a lot of people, so it's very labor intensive. And with both the robotic and somewhat with all three of them, it's just the generation of abnormal patterns of muscle recruitment and force production limit the amount of just emergence of a normal gait pattern. And then just the challenge of coordinating voluntary walking efforts with the electrical stimulation pattern have proved to be very challenging. And so this provided an impetus for us to develop new therapies to improve walking performance in this population. So with that in mind, we documented the impact of an 8-week program of underwater treadmill training on locomotor function in adults with incomplete spinal cord injury. And so over a 2-month period of training, walking speed and walking duration in the water were increased by 40% and 60% respectively, with that idea of trying to hit that that mark of about 1 mile per hour. And results from this study demonstrated that leg strength, balance, preferred and rapid walking speed, the amount of distance covered in a 6-minute walk, and daily step activity all significantly increased in our population with just the 8 weeks of training. The only variable that didn't increase was the walking index for spinal cord injury. And that measures the amount of assistance that somebody needs. And one of the problems with that is, like, if somebody was walking using leg braces and a rolling walker, for example, and they increased their, if they walked at the same slower speed, they could use less assistance. But in order to try to achieve the faster walking speed, they were using the assistance, so it didn't change the score. So that was kind of the explanation from that. In addition, we looked at some qualitative changes, and our participants reported a number of positive outcomes that were not just measured in the walking performance. And these included improvement in functional mobility. It changed their perception of well-being. They reported greater independence in performing daily living activities, better overall health, and greater mental well-being. And that was one of the things that we kind of noticed, is that we were seeing changes in gait performance way before you would expect to see a training effect. And it seemed that a lot of it was just putting people in a safe environment, and to some extent just restoring some hope that they had ability, and they seemed to improve fairly rapidly. The next couple of slides have some video of one of our participants with incomplete spinal cord injury. And in the first video, you'll see that the participant is just getting into the underwater treadmill and the level of assistance he needs for that. And then you'll just kind of see the change in his gait once he's walking in the underwater treadmill. So here he's entering the treadmill. And that's just how much smoother the gait looks when he's just walking. And then the next slide, we'll get to the end here. He wasn't going that fast. I just fast forwarded that.
Dr. Stevens, this work is outstanding. That is just, the video is really remarkable when you think about the gait getting into the pool.
And that was just pretty typical of, like I said, of what we would see. And then this was this, whoops, sorry. Let me get it to advance. And this was the same participant then just walking over ground after completing the training.
That's substantial.
Yeah. So, and like I said, this was pretty much the outcome for all of the people, in that. Now, one of our study participants, and the thing that was hard with all of it is that, this was for 8 weeks, and, all of the people were like, okay, well, what do we do now? And being a research lab and not a rehab center, we couldn't really keep people going, but we did have one participant who we decided to just do a case study. And so we put together a long-term study, and she, like I said, just seemed that she had so much more potential. So we kept her going. So like I said, this is one of our participants with her husband, and her injury was caused by, she had a cervical injury, was quadriplegic. It was incomplete, but still fairly significant. She was in a rollover accident. When she was finally discharged from the hospital, she went home with her husband, and he had to provide maximum assistance to assist with bathing, lower extremity dressing, catheterization, and her bowel program. And she was using at that point a power tilt and space wheelchair, She had a wheelchair van with a lift. They were using a Hoyer lift, an electric hospital bed, and a rolling shower chair. So her injury was in June, and she kind of went home after that and started seeing some recovery. Most of that was spontaneous, but by January, she had started to see some lower extremity motor control returning and had some functional improvement. So she started then doing some outpatient interventions, and she was able to transition from sitting to standing with moderate assistance and walking approximately 25 feet with bilateral leg braces, a rolling walker, and moderate assistance from one person. And at that point, she enrolled in our study. And so she started training with us about almost a year and a half after her accident. So findings from that, so this was the percent change after 2 years. So she completed the 8 weeks, and then she went on to train to complete 2 full years of training. And it revealed substantial improvement in leg strength, balance, increased her preferred and maximal walking speeds and the distance that she could cover while walking for 6 minutes. She took more steps each day in her own environment. In addition, the amount of time she spent in her wheelchair decreased from 90% prior to underwater treadmill training to only 25% after 24 months of training. And that was a marked improvement in her ability to support body weight using both her legs and her arms.
That is outstanding.
In terms of other things that she reported, she said that she had better bowel and bladder function, improved sensation, she lost some weight, she had greater independence and less reliance on others when performing her activities of daily living. She says that she had increased confidence in community-based activities and more leisure time activities. So after completing the training in our lab, she continued some home-based exercise programs, and she was walking in the pool at a local YMCA. And I followed up with her 2 years later, and she reported that she was now able to ambulate independently at home and in the community. She did use a rolling walker still, but she could kind of surf if she was just in her own house. She was completely continent in both bowel and bladder function. She managed her self-care activities and household tasks and participated in leisure time physical activities such as gardening, boating, and she's continuing her workouts at the YMCA. And so I went to see her to just kind of get some video for follow-up. So this is her just walking around. And I asked her, well, how did she get out to the garden if she wanted to go do work in the garden? She said, oh, I just ride the four-wheeler. So she was able to get on the four-wheeler, and let's see, I can kind of speed it up a little bit so you don't have to watch all of it. Let's see if I can get it to.
That's so great, though.
Yeah.
One follow-up question. So for this individual, is a 2-year case study, and then here we're seeing 2 years follow-up. Did you all do any pre-intervention assessments? Did you reassess at, say, 6 months or 12 months? And if so, where did you capture most of those improvements?
We did, and the thing that's interesting is we followed up, every 6 months, and typically when you did any comparison between the 6-month assessments, there wasn't a significant change. So 6 months never seemed like it was enough to demonstrate a significant improvement. But when you compared, 6 months to 1 year, there was, it just took longer. So she honestly continued to make. Now, we didn't do any assessments once after the 2 years with, that I never assessed her again after that. It was just more curiosity follow-up than because the case study had already been presented and, you know, it was kind of done. I was just curious to see how she was doing. But it seems that it is a very slow recovery, and that, you know, that while there was, like I said, a initial, in that first 8 weeks, she had significant improvement there. And then it really did slow down, but it never stopped. It was fairly, you know, incrementally progressive from that point on. And, you know, I'm assuming she's still getting stronger and healthier. So I don't know.
Thank you. Appreciate you sharing.
Sure. So after, one of the things that I kind of learned throughout all of this, and starting even with the study with the children with cerebral palsy, is that the greater the level of impairment, the greater the level of improvement. And so this kind of led to the point where the next step was going to be to look at a population of people who have complete spinal cord injuries. And so we were taking people at this point into a study that had no walking ability, and they had been paralyzed anywhere from, the minimum was a year, and the maximum amount of time we had for a participant was 29 years. So these are people who had been using wheelchairs, you know, for quite some time. And because of that, we had to get in the water with them, because, you know, they, like I said, clearly we're not going to be able to take any steps. But our question was, you know, would these individuals be able to have any level of enhancement of physical ability? And it was never with the idea, you know, we were looking at things, you know, just more health measures than anything, not assuming that they would recover walking. And all of the participants in that study recovered the ability to walk over ground with adaptive equipment. And I'll kind of take you through the process with one of the participants we had. So this was after 2 weeks in the treadmill. And like I said, you know, and you can see that he's taking all the weight on his upper extremities, and we're using weights on the ankles just to keep his lower extremities from floating. And someone behind him is initiating the stepping motion. And then at 16 weeks, you can kind of see he's still, you know, taking the weight on his arms, but he's able to actually take the steps independently. Now, once that emerged, then we were, you know, going to try to see if we could do some transition into overground. So we started, you know, just trying to move him along. And you can see he had a lot of foot drops. So we were tying up his toes and moving his legs, kind of stabilizing the walker, moving the walker forward, and assisting him to do some forward walking over ground. And after 40 weeks, I put this slide in because you can kind of see when he started, he was taking the weight on his arm and the water level was, you know, chest high. And after 40 weeks, we had reduced the water level. And now he's really, you know, not taking the weight on his arms so much. You know, he's weight bearing on the lower extremities and still being able to do the forward stepping.
This is outstanding. That video just, oh wow.
Yeah, and then here he's walking kind of up a fairly steep incline, you know, outside the lab. Now he went on to train after this too, and got to where he was walking, you know, 400 or 500 feet without a rest, and could, like I said, kind of do minimal ramp walking. He could get on an elevator. And one of the things that we found that was really interesting too is that people don't have to walk very far to have walking have a meaningful impact on their life. You know, for this guy, he had gone on vacation with some friends, and they had checked to see if the bathroom was accessible at the condo they were going to stay in. And when they got there, they found out that the bathroom was accessible, but the door wasn't wide enough for a wheelchair to get in. And so whenever he had to go to the bathroom, someone had to carry him into the bathroom. And it was a very unpleasant experience for him. So he had just quit pretty much going anywhere. And with being able to walk independently, he said, if it's just enough so that I know if I need to, I can walk into the bathroom. You know, that confidence of I can go places now because I can rely on my own skill. You know, and we had, you know, somebody who just wanted to be able to fill the car up with gas so that he could go farther than what you could count on a tank of gas. And all he wanted to be able to do was walk from the driver's side to the gas tank. You know, so it's like, people weren't saying, you know, I need to be able to walk a mile for it to be meaningful. It was, you know, these sometimes very short distances that had the greatest impact on them.
And Dr.
So,
Stevens, my apologies, we have a quick question from the chat,
sure.
if that's okay.
Yeah, go ahead.
Wonderful. So the question is, how important are the ankle weights during aquatic gait training?
Well, initially, they're very important because, like I said, you know, the thing that I just get so excited about and is so incredible about the aquatic training is that if you are in a harnessed piece of equipment over a land-based treadmill and they're supporting 100% of your body weight, your leg weighs what your leg weighs. And if you're not strong enough to move that much weight, you can't do it. In the water, your leg becomes buoyant and it's automatically going to float up and forward. So you're already going to have that forward motion. The problem is it's going to stay up if you don't have the strength to bring it down, if you don't have that hip extension. And so in order to have contact with the treadmill, initially the weights are very important. And the training effect of the weight is to be able to reduce it, where you know that you are getting enough active extension for the person to resist that and be able to bring their foot back down in contact with the water. So where initially you would think adding ankle weights increases the resistance, in our case, it's more assistance and it's, you know, more independent mobility when we've been able to take the weights off. So that's kind of a little bit counterintuitive, but you know, we do try to get them down as minimal as possible, give them the least amount of support necessary, and then try to move away from that, you know, as quickly as we can. And if we want to improve, you know, greater extension or provide greater resistance, we can do that more with turbulence and using jets and, you know, those types of things than weights.
Perfect. Thank you.
Do you think answer the question?
I believe so. I'll tell you what, I'll have them add into the chat here, or we can revisit it if needed, but I think that was beautiful.
So in terms of, you know, where we are, we've recently completed an NIH funded study that expanded our research involving adults with incomplete spinal cord injuries. And in this study, we had a control group, which was more useful. And we had approximately 30 people training in it. And we looked again at walking speed and endurance. We looked at participation in home and community-based activities. We measured leg strength, balance, and we looked at the coordination of electrical activity in the legs through EMG monitoring. And we are starting to publish the results from that study right now. And the study on the people with complete spinal cord injuries was published in August, I believe. So that's fairly recent. Currently, we're working on a variety of studies with other populations. We've been training people with type 2 diabetes, stroke, traumatic brain injury, and arthritis. And in the future, we'd really like to continue to conduct externally funded studies, maybe multi-site trials, transition from the water treadmill training, to the laboratory and community-based settings. The thing that's one of the great things I think with the underwater treadmill is like it doesn't take a lot of skill to be able to use it. And if this was available just in community-based settings and fitness centers, it would be accessible to so many people who could continue to train, without having to utilize excessive resources for physical therapy and those types of things. So we'd really like to see it become, like I said, just more easily accessible. So I think kind of just the overall bottom line to all of it, I would just like to say some things that I've learned over the past decade, I guess. And I think the most important lesson is just that the central nervous system can adapt when exposed to chronic physical activity. And I really believe that if you can provide a safe and supportive environment for physical activity, people will explore the potential of their own recovery, and much more activity is possible than they might have realized. And my advice is always just start wherever you are, and always remember that every step counts. And that's pretty much it. And I appreciate the opportunity to tell you about the work we're doing in our lab. And like I said, any questions, I'm happy to take at this time.
And Dr. Stevens, I just want to say thank you for joining us today. This was outstanding. I think there's always something fun to learn, and it's amazing to see the work that you've done, and you're recently completed NIH grant and future directions as well. So yes, we do want to open up the Q&A, and I have a question here for you right now.
Okay.
And for the panel, if you all want to rejoin us, you're more than welcome to do so. And I'll read this question to you, Dr. Stevens.
And I'll stop screen share, and just in case I can go back to that if we have to revisit slides, but.
Perfect. So the question here is, would adding a cognitive task to the aquatic gait training influence outcome measures such as gait speed?
Well, dual task is always a nice thing to be able to do. Dual tasking is pretty much how people will walk, and I think that would be a great idea. I know that one of the issues that we have it's interesting, particularly with the people with complete spinal cord injury, is that as much as it's built on reflexive activity, it's still somewhat a cognitive task, and they do have to really pay attention to what they're doing. So I think that adding that in the water would probably be a little more, would be a good place to start and see where to go with that. But I think for the the people with incomplete spinal cord injury and some of the other populations, that would certainly add a level of function to the outcomes that would be very useful. So I would absolutely encourage somebody to do that.
Excellent, excellent. And let's see here, and I apologize for our panelists. I'll let you, I may have to change something. I'll let you show your videos, but in the meantime, I have a follow-up question.
Okay.
Oh yeah, this is a good one. What pool temperatures are you using in your studies?
Well, we always, when we start the studies, we always have an accommodation session where the participants come in, and typically we let them select water temperature and find what is most comfortable for them. One of the things that we found is that for many of the quadriplegic patients, they have high degrees of spasticity, and the warmer water tends to help diminish some of the muscle tone that interferes with motion. So they'll tend to select higher water temperatures. We have, a couple of people that have a lot of hardware in their back, of surgeries, following. And again, anything that's too cold will tend to be conducted into that hardware that can become very uncomfortable. So they tend to go pretty warm. Now we have always had, a few people who just really prefer cooler water, but I would say The coolest water we've used is probably about 82 degrees. And the average, I would say, is probably, 89 to 90. And then as high as, 94, 95.
Oh, wow. Okay. Yeah. So depends on the application,
Mhm.
what the individuals are experiencing, and very neat. I
Yeah,
appreciate that.
the heat can sometimes help modulate pain as well. So, a lot of them don't experience some of the neuropathic pain when the water's warmer.
That's a great point. If it's all right, I'd like to open it up to our panelists here, if there's any questions for Dr. Stevens.
Yes, I do have a quick question. So first of all, thank you for presenting your amazing aquatic research personally. And it was really amazing, the improvements because of the intervention. And one of the aquatic component that we can take advantage of this.
I'm losing the thing, everything froze for a minute, so I didn't hear the question.
All right.
Could you repeat it? I'm sorry.
No. So one of the aquatic components that we can take advantage of from the aquatic exercise, I guess it is the hydrostatic pressure.
Mhm.
So I was wondering if the duration that the participant exercise in water would impact the change in the walking speed or walking distance, that kind of thing.
I think it definitely does. One of the things that another study that we published was just on the cardiovascular responses, because you're right, the hydrostatic pressure for many people with spinal cord injuries, one of the reasons that they can't sustain a training session long enough to improve is because when you get them upright, the blood pools in the lower extremity, and they don't have the muscle pump or sometimes the strength of the respiratory pump to get good vascular return. And so their cardiac output is very low. And without, significant increases in heart rate, they're going to basically pass out. They can sustain very brief periods of upright. So the hydrostatic pressure of the water, serves as compression that gives this great venous return. So even in the absence of significant heart rate increases, they can sustain longer periods of time training in the water than they can over ground, which as you were suggesting is if you can train longer, you're going to have more response. So there's this strong interplay between, the limited limited exercise cardiovascular response and the improvement of that when you are in the water, particularly to, a depth of, about chest level. Then, like I said, you can sustain longer, and it does improve the amount of challenge or intensity that you can provide through increases in duration and walking speed. So I think that as you were suggesting, the hydrostatic pressure is a key factor that allows for that, and it's just not present in any other, exercise environment for this population. One of the things that we saw is that initially when we would put them in, and like I said, every 2 weeks, the speed would increase. So we would put them in the treadmill and they wore heart rate monitors the entire time. And we, recorded heart rate throughout the training sessions. And they would start, and then over the 2 weeks, without changing the intensity, they would get a training response. And within 2 weeks, you were seeing lower heart rates at the same training intensity. And then we would up the speed and you would see the increase in heart rate. And over the 2 weeks, it would drop again. And by the end, they were walking faster and longer at the same heart rate that they started with. So it was interesting to see that their cardiovascular training response was very similar to a non-disabled population.
Excellent. Great question, June. And thank you for that response. That was incredibly insightful. Sure. Let's see, I'll keep an eye on the chat. I want to open it up to the other panelists as well.
So I have a question. So yeah, first, thank you so much for your talk, and it was so interesting. So it was impressive that you identified improvements in many like subjective and objective outcomes, right? But I think these could be also improved just by the treadmill training on land as well, regardless of the aquatic environment. So in our lab in the past, we identified several like special temper characteristics or mostly activity patterns between like underwater gait walking and the walking on land. So do you expect any greater improvements in the like underwater treadmill group in any of the outcomes if you included on kind of independent land treadmill group? So yeah, I think in addition to the like hydrostatic pressure, there's so many like benefits related to the physical properties of the water. So do you expect any like great improvements in the aquatic exercise group?
Well, I mean, I think so, but and I think you're right. I think that just the properties of the water provide some things that you wouldn't see in the, well, in overground training. But what I feel like, just from, and this is not scientific, it's just kind of more casual observation, is that people feel safe. You know, that I think that they have so much potential that they could explore. And you're right. I mean, a lot of the improvements that we would see in functional outcomes, you know, would be the same if they had those improvements, whether they were training overground or in the water. Yeah, I don't see, you know, the aquatic environment as being something magical and it's like your own, you know, this is the only way that you can do it by any means. But what I saw is that people are afraid to fall and they're afraid of getting hurt and they're afraid to push. I mean, they've already been hurt, you know, in this population. And, you know, we would put some people, you know, who were sure they wouldn't be able to walk and put them in the underwater treadmill, and they would find out that they could take steps from the time we put them in, and they hadn't walked in a decade because they never felt that they were in an environment safe enough to really explore their own potential. And I think that several things contributed to that. And I think the water is a very big part of it. I think it's an environment where people feel safe. And if they fall, they're going to get wet. They're not going to get hurt. And I think that, you know, warm water is kind of a comforting environment, and that, you know, and then I feel like our lab is a very safe place for people to be. And, you know, I have the footsteps, you know, painted on the wall, and we have music playing, and, you know, everybody's, you know, tries to be super positive and happy to see people, and things just emerge, you know, that I think that with the motor activity, one of the things that's interesting is, particularly when we were working with the kids with cerebral palsy, that the gait that emerged might not be a normal gait pattern, but it was a functional gait pattern. And what we found when we were measuring the metabolic efficiency of the gait through oxygen consumption is that when you impose a gait on somebody, whether they're typically developing or have a gait impairment, what they freely choose in terms of stride length and cadence and heel strike, all of those variables that are self-selected will give them the most efficient gait pattern possible. And even within the disabled population, they will self-select what is the most efficient pattern. And if we try to impose something and say, okay, you know, you need to get your heel down and you need to get, you know, distance between your, you know, however, whatever we're imposing on it, it becomes less efficient. And in the water, because we're not imposing anything, we're not moving the legs, the robot isn't moving the legs, the electrical stimulus isn't moving the legs. What emerges is their natural gait pattern, and it's going to be the most efficient. So it's, like I said, just this great environment for that level of exploration, and just let emerge what emerges without a lot of restrictions on it. So I think that's been one of the most beneficial parts of it.
Thanks for your answer. Thank you.
You're welcome.
I have a quick question.
Sure.
First off, thanks for the talk. It was very inspiring. So recently we were working on an aquatic study, and we were involving the non-injured partner in the pool as well for the exercise intervention. And one thing I noticed when you're just speaking of safety is how far you could really push someone in the pool before they, yeah, were even feeling unsafe or, going too far. And I was just wondering how you kind of progress your exercise interventions, or how how far you can push someone before it's too much or too unsafe. Because I kind of felt like I couldn't push hard enough sometimes. Or like one time we had a slight mishap, and the participants ended up running. And this is someone who usually uses arm crutches all the time. So it was just really impressive. And I'm just kind of wondering if you have any insights on how you gauge that progression.
Well, I think that's where the art of this kind of separates from the science of it. And, it's something that I think it's an intuitive feel that you have. But I kind of did the same thing when we started. I was very conservative with increases in intensity because I didn't want any problems. And I think that I frustrated people because it was moving too slowly. So then, in the more recent studies, they have more autonomy in that, in self-selecting intensities. But the thing that I go with and that I try to impress upon the participants is challenging but comfortable. It's like, what do you see as challenging but comfortable? If it's not challenging, you're not going to make progress, but it shouldn't be painful or scary. And try to find that window of always, said challenging but comfortable. And I think most people can identify that. And I've tried using things, just like an RPE scale, and that never works. And I think that becomes too cumbersome for them. But, I think it's always pushing them a little bit farther. And some people, I feel like I had to more slow down, and some people, I had to more, push a little bit farther. We had one participant that when I was trying to get him to move from walking in the water to over ground, we used one of the harnessing systems that you put over the treadmill, just because he was so afraid to walk over ground. And so he went along with that. But, it's like, you can't go anywhere. It's like, so it's like, okay, we got to get you out of the harness. And so I said, okay, we're going to walk outside today, and took him outside. And he was, very scared. And he said to me, he goes, my legs are kind of messed up. It's like, yeah, I know. It'll all be okay. But he used to say that his least favorite thing was to come into the lab. And if I said, I've been thinking, and he was like, oh gosh, no, don't do that. that was his least favorite expression of mine. Like, so I've been thinking, but I think you're right. I mean, that is probably one of the greatest challenges. And I think that, that so much of that just comes with, relationship, if they trust that you're not going to push them beyond what is reasonable. And I think too, like, particularly in our lab, and I think maybe you're seeing it in your lab too, is that when they see other people, that we have so many people in and out, and they've seen where people started and the progress that they've made, and that nobody's been hurt. And I think they really develop a level of trust of, well, that's why I'm here. And I'm going to trust that, you're not going to hurt me, and you are going to push me enough to make some progress. But you make the best decision you can. And if it's not enough, push a little harder. And if it's too much, recognize it and back off a little bit.
Yeah, thanks for the insights. Yeah, that was one of
Sure.
the big things we saw with the partner being there too, was probably they pushed the maybe lesser performing person to go a little harder, but also made them feel more comfortable being there. So
Yeah,
kind of a unique element. So
I
thank
think that's a great idea.
I just want to, so I don't forget, we have two other kind of comments rather than questions in the chat box. Just want to make
Okay.
sure I acknowledged them. So a little earlier in our session, someone mentioned they commend you for conducting these studies that directly improve quality of life in these populations. And a little bit ago, just someone else just wanted to say, thank you for sharing your time with us and inspiring us.
Oh, well, this is, like I said, it's my favorite thing to talk about. So and honestly, it's good to know somebody was actually reading some of the research we put out. So thank you, June. And it's also been, I don't get invited to talk about this much. So to have a captive audience of people who wanted to hear about it, it's a great thrill. I was so excited when I got the invitation. So it's been fun.
And we've been lucky to hear from you. Talent, do you have a
question?
perfect?
Yeah, thanks for presenting. And I apologize, I jumped on a little late. I had class. I got out around, was it about 12:30? So, but yeah, just wanted to chat a little bit with you about it because we're doing a lot of stuff similar to your area with clinical aquatic research. One thing that we're focusing on right now is we're targeting foot drops specifically.
Oh, uh-huh.
Yeah, and so yeah, we're collecting some preliminary data this year, and then hoping to use that in support of an NIH application next year, which you had touched on the multi-site
Oh, yeah.
studies. So we'll have to be in contact at some point.
Oh, yeah, that would be incredible.
But yeah, so one thing I really noticed, I was able to watch at least when you went through the progression of the client, and more towards the start of the progression, they had the passive assistance to help support with the foot drop, right? But then towards the end of that was removed. I was just curious if you saw any, clinically meaningful benefit in terms of the foot drop specifically, and if you measured that in any way as a dependent
We
outcome.
did just in terms of specific muscle activation, both with the EMG and then also just muscle strength in those dorsiflexors. And we were able to see significant changes in both of those, so that they were able to activate those muscles, and that they were strengthened just through probably the resistance of having to pull that toe forward, through the water. So, it seemed like it really was a big part of that. And I don't know if you noticed, but, when it started, before they were able to really get it, you could kind of see, when the treadmill would come through, their foot would drag back, and they were having to pull their toe
right
across the bottom of the treadmill.
Right.
And so much so that most all of the participants, the front of their shoes were where you would get it worn out, where it was that drag on their toe.
Right.
So they were getting added resistance there and had to bring that forward. And because with the weight, their foot was going to come down.
Right.
So I think that added resistance really helped target the foot drop.
Yeah, I agree. And there's mechanical support for it too, considering that, right, drag is influenced most by the relative velocity of moving through the water.
Right.
So since the foot has to move the furthest distance, it's going to be moving the fastest. So I think it's really, it makes sense from a theoretical standpoint that, the dorsiflexors are probably going to be challenged the most. And so Christopher, who's actually on the panel, he's doing a thesis project on it.
Oh,
You proposing in about an hour, right?
well, that's great. But no, I think you're, and I think the other thing is that foot drop is one of, the greatest indicators of fall risk.
Exactly.
So like I said, it's certainly one that will have a huge impact on, overall gait independence.
Yeah. Well, yeah, I'll grab your email and I'll reach out to you sometime.
Sure, that would be
I'd like to
great.
chat more about it, but
Yeah.
yeah, thanks again. That was wonderful.
Oh, well, thank you.
Yep.
And I'll be glad to kind of help facilitate kind of an email introduction with Dr. Stevens and our panel here today. So if there's, follow-up or questions, we'll have a great contact there. I wouldn't be conscientious of your time, so we're a minute past. So with that, I just want to say thank you, Dr. Stevens. This has been incredible today. I think we've all really appreciated to hear about your work, feel truly inspired. And thank you for our panelists for joining as well. And
well, thank you. It's been fun. And Sarah, you've been great to work with through the whole thing. So thanks for the invitation. And I look forward to hearing from some of you in the future. Thank you.
and likewise, it's been a pleasure. So thank you all.
Okay. Bye.
Bye. And I'll end our recording.